Hello everyone and welcome. This is Professor Thayer with you here today to talk to you about drawing ASCII geometric shapes. In particular, we are going to look at drawing the right triangle, both left justified and right justified. So let us go ahead and get started with today's exercises. So I'm just sharing my screen here with you today to show you the problem we're going to look at. We are going to try to draw the left justified triangle, which looks like this picture here. See, it is an ASCII triangle, right triangle against the left-hand margin. This is our signature, and preconditions is the n is going to be a positive integer, draws a left justified right triangle. This is going to go up to n width of n, that will be the number of stars. This is being shown for n equals 5. As we can see here, this function is available for us to edit and go ahead and solve that problem. So the first thing I'm going to do is I'm going to set the number of stars equal to 1. I'm going to use this as an accumulator as I do some looping, and we're going to set that equal to 1 because I know that the apex, no matter what size my triangle, is always going to begin with 1 star. Now, thinking about how I might continue to draw each of these lines until I reach the maximum makes me think that I probably want to do a while loop. So I'm going to go ahead and do that. So I'm going to do a while the number of stars, which will be the number of stars per line, is less than or equal to the total number of stars that I wish. So that will be my n. Then what I can do is I can print the star character. And how many times should I do that? Well, I will print that n star each time. Now, because I have this in a loop, I will have the ability to increment my number of stars each time I go through. So I'm going to go ahead and use augmented assignment. That's the plus equals notation, n star plus equals 1 to increment my number of stars each time. Now, at present, I don't actually have a function call, so I'm going to go ahead and put in a function call, left j of the right triangle, and this is asking for some number. So I'm going to go ahead and do the 5 to get started, so we'll match the picture. And let me just do run modular. Notice I do have my next problem set up, but that has a path in it, and also I have not put any function calls. So I would expect that that will simply just save that. Okay, and there we have it. There is our right justified triangle, and we can also just, the left justified right triangle. And I'm just going to try this with some other number just to make sure everything is working fine. And we see that that is entirely working just fine. I can also put my cursor up here and do enter. So it's a good idea to check this out with a couple of different values just to be sure. So I've done now the 5 from the picture, 25 and 3, so something large, small, and the given example. So now I'm convinced that that's working. Let's see what our next challenge is. That is to draw the right triangle, but now to make it right justified. And this is a little bit harder because, see, we're going to need to be printing all of these spaces before it, which is going to make it a little harder. So we can see, though, that we would probably start this off in a very similar way. I am going to need the number of stars also to be equal to 1, because I know that the apex is always going to begin with 1 star, and I would use a similar strategy just to continue growing that star down, the triangle down. Now, what I do notice too also is that the width of each of these lines is going to be equal. These will have more spaces in it, so the number of spaces will be decreasing as the number of stars is growing in. Whereas in this example, I was growing in the stars, and the width of the line was growing. So the line widths were not equal. They were actually growing with it, but because we have to print the spaces going left to right, it will now be equal width. So how can we use that insight to make our little programs? Let's begin with n star equals 1 for our initialization, and again use that strategy of a while loop. So while n star is less than or equal to 1, I think will be the same good strategy to use. But what I'm going to do is I am going to introduce this idea of the number of spaces. Let's let it be called n space equals the n. So I know that the total width is going to be equal to n because that will be the maximum width. And now let me subtract the number of stars, right, that I'll be drawing in this row. The reason why I do this is because the total number will be n. Here we're going to have the number of spaces that I need is the width of this, width at the bottom less the number of stars that I'm going to draw here. So that will be n spaces equals n, the total width, minus n star, the number of stars that I have in this particular row. So we'll start off with n star equals 1. So that means I'll need 4 spaces, which makes sense. And so on as I move on down. So now what I can do is I can change that print. So what I'll need to do is first I'll need to print my spaces times the n spaces. And I'm going to concatenate that with the number of stars times n star. So you'll see it's slightly modified from the one that we had above. And then of course we need to increment our variable for the next time through the loop. N star plus equals 1. All right, so there we have it. What we should do is just make our function call here so that we don't get output from the previous problem. I'm simply going to just turn off the function call to it, so then we will not get any calls for that function and therefore not get any output from that. And let's go ahead and try that for 5. Let's do run module. Let's save that, and we get 1. Why do we have only 1 star? There is a problem here. This needs to be n. Typo. Let's try that again. Real life debugging. All right, and there we have it. All right, so the problem was that I had mistakenly put while n stars less than or equal to 1 instead of n, the total number that we need. So now we have supplied 5 to get our total number of stars on the base, and we see that our little formula has worked quite well. Now, the next thing we're going to do, again, is just test this out for a few more. So let us go right J, right justified of right triangle. And we could do this for some other larger number. Let's pick 25 again. There we go. Beautiful. And we could also pick this for something small. So I'm going to do right J of right triangle of something small. So if I do pick 1, we do get 1. And if I do pick, let's pick 2, for example. There we go. All right. So now I am convinced that this is working. I hope you have enjoyed drawing the ASCII right triangles with us on Fast 5 with Professor Bear. As always, we hope you have a great day and keep on coding. Enjoy and see you soon.